Hey, take a look around you for a second. Seriously, the building you're in, the car you drive, maybe even the chair you're sitting on, they're all held together by this invisible force. And today, we're diving into what that force is: industrial welding. It's the amazing technology that literally builds our entire world, one permanent bond at a time.
I mean, really think about it. From those massive skyscrapers that touch the clouds down to the tiniest little electronic parts, huge pieces of metal are joined together with just incredible strength. So how do they do it? Well, the answer is welding, and we're about to break down exactly how this essential process really works.
Okay, here's our game plan. First up, we'll define what welding actually is and why it's so incredibly important. Then, we're going to get into the two major families of welding, fusion and solid state. And we'll explore all the powerful techniques hiding inside each of those categories.
All right, so let's start at square one. What exactly is welding? When you boil it all down, it's the fundamental process of joining materials together.
Okay, so here's the official take. Welding is a fabrication process. Its whole purpose is to join parts, usually metal, but sometimes plastics too, using heat or pressure, or sometimes a combination of both. And you know, the most important word on this slide is permanently. This isn't like using a screw or a bolt. A weld makes two pieces become one single solid piece.
The way this usually works is pretty intuitive. You melt the edges of the materials you're joining, they flow together into this little molten pool, and then they fuse into one solid piece as they cool. And a lot of the time, a filler material, kind of like a welding glue stick, is added into that pool to make the joint even stronger. So we know what it is, but why should you care? Why does it matter so much? Well, because this simple-sounding process is, and this is no exaggeration, the absolute backbone of all modern industry.
Think about it. Welding is what gives our skyscrapers and bridges their raw structural strength. It's what creates the leak-proof joints that are absolutely essential for pipelines carrying our water and our energy. And it's at the heart of manufacturing pretty much everything we use, from gigantic container ships to the car parked in your driveway.
And the stakes here, they couldn't be any higher. In heavy industries, like power plants or nuclear facilities, a bad weld isn't just a small problem, it could be a total catastrophe. Welding is the process that ensures the structural integrity and the safety that we all just take for granted every single day.
All right, now we're getting to the really interesting part, the big divide in the world of welding. Pretty much every single technique you'll hear about falls into one of two main categories. And the big difference between them? It all comes down to the melting point of the metal.
It's a really simple but totally crucial distinction. On one side, you have fusion welding, which uses intense heat to literally melt the base metals together. But on the other side, you have solid-state welding, which gets you that same permanent bond, but without any melting at all. I know, right? How is that even possible? Well, we're about to find out.
Let's kick things off with the one you've probably pictured in your head, fusion welding. This whole category is about harnessing incredibly intense, focused heat to literally build our world from the ground up.
Now, the undisputed king of fusion welding is definitely arc welding. And the best way to imagine this is to think of a tiny but super powerful and highly controlled lightning bolt. An electric arc creates this incredibly hot point of heat, we're talking thousands of degrees, that just melts the metal exactly where you need it to.
Now, underneath that big arc welding umbrella, you've got a whole family of different techniques, with names like stick, MIG, and TIG. They all use that same tiny lightning bolt idea, but they just have different ways of protecting the molten metal from the air or adding that filler material. That makes each one perfect for different kinds of jobs.
But electricity isn't the only game in town when it comes to creating intense heat. Gas welding uses a super high temperature flame, usually by mixing oxygen with a fuel like acetylene. It's a classic, really versatile method that you'll often see used for repair work or in smaller workshops.
Okay, this next one is really fascinating. Resistance welding works by pumping a powerful electric current through two pieces of metal. The metal's own resistance to that electricity generates this intense burst of heat, and that's what creates the weld. This process is the absolute powerhouse of the car industry. A single car can have literally thousands of these welds.
And they do this using techniques like spot welding, which creates a single little nugget of a weld, and seam welding, which is almost like drawing a continuous line of overlapping spots. It's an incredibly fast and precise way to join thin sheets of metal together, which is exactly why it's so vital for making cars. And finally, at the really high-tech end of fusion welding, you've got lasers and electron beams. These methods use incredibly focused beams of energy for jobs that need absolute pinpoint precision. We're talking about things like aerospace and nuclear reactors, places where there's absolutely zero room for error.
Okay, so far, everything we've talked about has been about melting metal, but now we're entering a totally different world, solid-state welding. This is where things get, well, they get a little weird, because here we are joining metal without melting it.
So how on earth does that actually work? Well, instead of using heat, these incredible processes use other forces, things like intense pressure, super high-speed friction, or even ultrasonic vibrations, to literally force the atoms of two separate pieces to bond directly with each other. It's a bond at the atomic level.
And this opens up the door to some seriously cool techniques. You've got friction stir welding, which uses a spinning tool to basically mix metals together like they're dough. You have ultrasonic welding for super delicate electronics. And then there's explosion welding. And yeah, it does exactly what it sounds like. A controlled detonation slams two metals together with so much force they just instantly become one. These are really specialized methods for very high-performance jobs.
So, let's pull all that together for a second. This table gives us a fantastic overview. You can see we have our fusion methods, like arc, gas, and resistance welding, which all use different kinds of heat. And then over here, we have the solid-state methods, which rely on forces like pressure and friction. It's a perfect little map of the entire welding landscape.
So, the next time you cross a bridge or just look up at a giant skyscraper, take a moment, look closer. You might just be able to see those invisible seams, the welds that are holding our entire modern world together. What was once separate is now one, all thanks to the incredible power of the weld.